All right, welcome back everybody. My name is Dustin, and in the last episode we created the texture loader and texture class. This video is going to be pretty straightforward. All we're going to be doing is moving the camera class from the editor here into its own class in the Scion renderer. And then we're also going to create the vertex class, but we'll talk about that when we get there. So first thing we're going to want to do is go to our renderer. Let's go to core, go to add, new item. And we'll just call this camera2d.h. And we're going to need a few includes. We're going to need to include GLM and GLM. And we're also going to need to include GLM, GTC, matrix transform. We're going to need those for our positions and our orthographic projections and our matrix. So we're going to do the same thing, put this in the namespace. Namespace, Scion rendering. Cool. And we basically just want to take everything from main here. So we just go to main, let's take this, and let's just take it all. And cut. Taking it all out. Cool, putting it in. What else do we want to do? So I want to do this. I want to go, because I want to put everything in the CPP file. So I'm just going to, let's get the CPP file made. Cool, let's go to our CPP, camera2d.cpp. Let's get rid of this real fast. That's the stuff I had already. Take all this, put it inside of our namespace. Cool. And then go back here, and we want to do the same thing with this. Update. Set scale. Cool. Let's move this up here. Anything that's inline can stay there. And let's add a couple more functions here. Let's add a set position. Now I'll just take in vec2, new position, and we'll say m position is equal to new position. And then we also need to say that it needs to update. Needs update equals true. Cool. Oh, that's a void. And we can make the getters for these as well. So just inline, GLM, vec2, get position. Let's make this const as well. And then we're just returning the position. Cool, and get scale. And scale is a float. So get scale, const float. Whoops. All right, that looks good to me. So now that we've moved our camera over here, I believe that's all we need to do. First thing we can do actually inside of our constructor is just call update. So it gets updated right away. And then here, we want to just say camera2d and just give it some default values. And I have to believe that it was 640 and 480. Sorry. There, that should work. All right, the camera's made, so let's go and make sure it works. Let's go into our editor, main.cpp, and then let's include our camera, and that's in core camera. Cool. We got our camera, and right here, before we do camera 2D here, now we just say Scion rendering camera 2D. That should be all we have to do, and I believe the camera will work as is. Let's try it. Awesome, that works and looks good. Now let's go up here real fast. If we look at our vertices here, we don't want to have to do this every time. We want to have a nice struct to hold on to this information. So this is our position. This is your UVs for your texture. Then you can also have color. And then there's going to be another one later on for the entity ID. We don't need to worry about that right now, but we will be passing that in later on for when we start really working on the editor for our picking texture. But we'll worry about that when we get there. So now we just basically want to make something that has position, UVs, and color. That will be for our vertex. So let's go back into our rendering here and go to Essentials and add new item, vertex.h. Cool. The vertex is pretty straightforward, so we can do it all in this header file. And we just need to include a few things. We can go include glad. We need glad. And then we also need GLM. Cool. And that's in the same namespace. So namespace, Scion rendering. So our struct is a vertex, and we're gonna have our position. So GLM, vec2 position, and that's gonna just default at 0.f. And we're also gonna have another vec2, and it's just gonna be our UVs. That also defaults to 0.f. I thought about sending the color in as a vec4 of floats for simplicity. However, after doing some more research, I found that it's better to actually use a struct of GL unsigned bytes for each color. So that's what we're gonna do. So here, we're gonna go make a new struct and call it struct color. And that's just gonna have a GL U byte. And it's just gonna be R, G, B, A. Cool. And then we'll have our color here. Color. Color. And we're going to initialize that as R is equal to 255. G is equal to 255. B is equal to 255. And A is equal to 255. Actually, let's have G equal to 0 for now, so we can test to see if our default parameters work. And then we're going to want to create some simple functions for setting the colors, and that will just be void set color GLU byte R GLU byte G This one's pretty straightforward, so we're just going to do color.r is equal to r gba g b a b g. Cool. Another way that we can set the color is with bit shifting. We can send in an unsigned integer to perform a right shift to get the values that we need. So we're going to be sending in a GLU int, which is 32 bits, and each of our GLU bytes are 8 bits. So let's say we have a hex value that we're sending in, and it is 0xFF 00 FF AC. In binary, that would be like 0B 1111F 1111F 0000 0000 1111 1111. What is A? I believe it's 1010. That, you know what? Let's bring up a little calculator. Change it to programmer. Hex. A in binary, yeah, 1010. And C is 1100. Cool. So that'd be 4, 8, 12, 16, 20, 24, 28, 32. So from reading from left to right, if we want to have this to be R, G, B, A, like that. So let's say this is R, G, B, A. To set these values using shifting, we need to use the right shift operator. And we can do that as follows. So we can just go void set color. And then now we just want to send in a GLU int, and we'll just call this new color. So color.r is equal to new color. We're going to want to move all these bits out. So that is 3 times 8. It's 24. So we want to shift it by 24 bits. Oops, sorry, we need that down here. And you can also use this mask. What this does is just, if there's any other bits, it just masks it through. And then we just down like this. Make sure we change this. G, B, A. So say now we want to get these ones. Well, we need to shift all of these 16. So 8, 16. So these end up here under A. And because this is a byte, anything to the left is going to be truncated. It's not going to be there anymore. So we need to move this 16, 8, and then this is going to be 0. We don't need to do this one. It's just to keep it like everything from this way over is going to be truncated anyway. But there we go. That's it. So that's setting the color. That's it. That's the vertex class. So now let's take this class, or vertex struct, sorry. Let's take this struct and put it into our main. Let's go over here. Let's add it in our essentials, vertex. And how are we going to add this in? Well, see our vertices here. We don't need these anymore. We're going to want to just comment this out. Cool. And because we were using an array here, we're actually just going to use a vector now. So we go std vector of Scion rendering vertex, and we'll call this our vertices. So now that the vector is made, we can now recreate these 4 vertices: the top left, top right, and bottom left. And we can just do that by going Scion rendering, and we want the vertex, and we'll say vertex top left, and we'll just have these be default, be top right, bottom left, and bottom right. Let's also add the data in for these. So we'll just go vtl.position is equal to glm vec2. Now this is the top left. So we want this here, top left, 10 and 26. 10.f, 26.f. Cool. And then we go vtl dot UVs is equal to GLM vec2, and let's just copy this. Cool. We're not going to set the color for now because I want to see if our default value worked. And let's go back to that real quick. Yeah, and the default should be red and blue, so that's like a magenta color. So let's make sure that works first for the defaults. So we'll just copy this a few times for our 4 vertices and make sure that we change it. Copy and paste is not the best idea, but top right, bottom left, bottom right. Cool, so we got those all in, and now we just got to change our values. So top right, 10, 10, 10 and 10. Copy this. (26) and 10. 26 and 10. Copy this. (26) and 26. And copy this. Cool. And then we just want to push these back into our vertices. So vertices, push back, VTL, TR, VL, BR. Cool. That should be in there. So let's go to the red. So now it doesn't know what it's doing here. So we need to change this a little bit because it's not a size of float anymore. We are using size of Scion rendering vertex, and then right here we can go vertices dot size times. So the number of vertices that we have in our vector, and then we need to send in the data. Cool. You can take these comments out if you like. So now that we have that in there, we need to change this here. So the stride is no longer size of float times 5. It is now size of, that needs an E, size of the vertex. Scion rendering vertex. And then this needs to be changed as well to void offset of Scion rendering vertex and the position. We want to do these in the order that they were declared in our vertex. We can leave these here. And this still stays false and float. So this one is basically the same thing. It's for the UVs. And this is not size 3 anymore. It's actually only size, there's only 2. No, there's 2 components per the position. So we have to change that in our shader as well. We'll get to that. So this here with our, this is our UVs. So we can just copy this here. Copy this. And change that to be the UVs. Now we did add color, so we need to add that in. So we can just copy this here. Whoops. All right, and that it should be at 2 now because it'll be in our 3rd slot, and this has 4. This is going to be GL unsigned byte. And now for normalizing, we actually do want to normalize this now. And because we're using an unsigned byte, when it normalized, the values from 0 to 255 will be normalized between the values of 0 and 1. So it does it for us automatically because we're normalizing it. So it gives us a value from 0 to 1. So if you put 255, it'll give you a 1. If you put 125, or what's half of 255? Half of 255, you get 0.5. It'll change it into a float value for us. And our offset in this one is color. Cool. Oh, we got to change this here because we have, this will be a conflict. So we'll change the UVs here to just have UV. Just a quick change. Probably an easier change I could have done. This is all temporary anyway. We're not keeping this stuff. This is all just for testing right now. Please ignore the cat in the background if you can hear it. All right, so I think we got everything there. Oh, we need to enable 2 here. Okay, so we got everything. We got the color. So now we actually have to go to the shaders themselves. So let's go to our vertex shader first, or vert shader, and we're going to want to add a new layout. That's location equals 2. And that's a vec4 coming in. We'll just call that a color. And we're going to have another out here, and we're going to have out vec4, and we'll just call that frag color. Cool. And then we can just do that here, and we just go frag color is equal to a color. Okay, and then we go to our fragment shader, and we just need to go in vec2 frag color, and let's go vec4 texture color is equal to, let's take all of this and then go texture color is equal to, oh wait, color is equal to texture color times our color, our frag color coming in. Frag color. Cool. And I think that should work. Let's try to run it. We should get our eye. And it failed. Cool. Implicit cat. Oh, yeah. I forgot. In this, we need to change this to vec2. And we need to go 0.0. Let's try that again. Vec4 to vec2. Oh, basically on .frag. What did I miss here? You guys probably already saw it. Yeah. Sorry about that. Yay, it's our eye. So now that's everything. So we got our camera working, we got our vertex working now, and awesome. All right, so that's it for this episode. In the next episode, we're actually going to start looking into how we're going to be doing or using the ECS system. So the entity component system, we're going to be using ENTT for that. So maybe start doing some research on it. If you've already done so, good for you. And if not, I'll see you in the next episode. Take it easy.